Priya.
ಅವಯ್ಯ ಅದೇ
ನೀನೇ ಅಂತಿದ್ದಲ್ಲವ
ಸುಮ್ಮನೆ ಅಂದ್ರೆ ಗಾಸ್
Good morning, students. So today we will be continuing with the CET crash course, PUC second year part. Okay, so we will be continuing with that part. So in second year part there are 13 chapters. Okay, and from second year part 70% of the questions will occur for for mathematics, Karnataka CET. So from mathematics part 2, that is PU 2, 70% of the syllabus will occur. Okay, so you may expect out of 60, around about 38 to 40 questions. Okay, so 38 to 40 questions you can expect from this part. Okay, from the PU second year part. Okay, so in today's class we will start our discussion uh, with the topic inverse trigonometry. Students, please keep yourself mute so you can hear me clearly. Mute yourself. Those who are joining, just keep yourself mute and join the class. Don't disturb the other students. Okay. So see, pay attention now. Keep a book and pen with you. So the related formulas on it, all you can copy, and you can go through the questions once again and solve them later. So we will straight away begin with the first question on inverse trigonometry. Okay. So in inverse trigonometry, 1 minute we will just discuss the important formulas on which you can expect the question. So if you go through the previous CET papers, that is from 2014, the syllabus had got changed. So from 2014 to 2023, if you go through the papers, most of the time the questions are occurring on the following points. Okay. So the first point you need to know is, okay, so first you need to know the domain and range of these functions. Okay, domain and range, okay, of inverse trigonometric function, ITF, inverse trigonometric function. So this is your homework. Just go through these domain and range column. Next, second, okay, the formulas, okay, the properties, that is say sine inverse x plus cos inverse x is equal to pi by 2. Okay, sine inverse x plus cos inverse x is equal to pi by 2. Similarly, we have a result tan inverse x plus cot inverse x is equal to pi by 2, and so on. The second property. Next, third one, you need to know, okay, the inverse of minus x. So sine inverse of minus x, it is minus sine inverse x, and the same formula is applicable for tan inverse of minus x and cosec inverse of minus x. Okay, so tan inverse is equal to minus tan inverse x, cosec inverse x is equal to minus cosec inverse x, and so on here. And in case of cos inverse, now in case of cos inverse, cot inverse and sec inverse. Okay, sec inverse of minus x and minus x. Okay, the result is pi minus. Okay, so pi minus cos inverse x, pi minus cos inverse cot inverse x, and then pi minus sec inverse x. Keep yourself mute. Just off the audio, Sanjana. Say either listen to the class or do other activities. Simply don't disturb other students. Keep yourself mute. Okay, because for every lesson there is 2 hours only. Okay, so within that we need to cover maximum questions. So don't disturb. Okay, next, the fourth point and the very important property. Okay, the fourth property is tan inverse x plus tan inverse y. is equal to tan inverse x plus tan inverse. Okay, tan inverse. Okay, the property is tan inverse x plus y divided by what? 1 minus xy. Okay, and then similarly there is a result with respect to sine inverse x. See, students, mute yourself. I'll be not repeating it again, and later don't disturb the class. Okay, so these are the important properties you need to know. So based on these, there are chances of the question occurrence of the question. So again, one more result, that is for 2 sine inverse x and cos inverse x. Okay, so these are the few results. Based on these, you may get the question. And here very important is the domain and range. Okay, so because the options, the whatever the answer you are getting for this, they should be belonging to the range of the ITF, and then only the answers will be correct. Okay, so you need to know the domain and range of these functions. Okay, so we'll begin with the first question here. Pay attention. If any doubts are there, you can put it in the chat box. Once after the discussion of the question, you can put it in the chat box. Okay, so the first question here is cos inverse root 3 by 2. Okay, so you know for cos inverse of root 3 by 2 is directly equal to, this is a very easy question. Okay, it's equal to what? Directly it is equal to what? Option D, and that is pi by 6. Okay, so here you need to know the trigonometry table. Okay, trigonometry value table. Okay, so if you know this, you can easily find out write down the answer. Okay, next question number 2. Okay, so see here the solution. So question as well as solution is given here. Next question. So see, if 6 sine inverse x square minus 6x plus 8.5 is equal to pi, then x is equal to, okay, then x is equal to. So here, first what we need to do is, we need to shift the 6 on the RHS. Okay, so see, this is a quadratic equation given here. Okay, so first what you can do is, see, we can write it as x 6x plus what 8.5 is equal to sine inverse of x square minus 6x plus 8.5 is equal to pi by 6, or x square minus 6x plus 8.5 is equal to sine pi by 6. Okay, and sine pi by 6 we know the value, it is equal to what? 1 by 2. So 1 by 2 x square 6x 8.5. So when we simplify, we get it in the form of 2x square minus 12x 8.5 into 2, it will be equal to 17 is equal to 1. Okay, is equal to 1. Or on simplifying, we get 2x square minus 12x. Okay, minus 12x plus 16 is equal to 0. Or on further simplifying, we are getting it in the form of x square minus 6x plus 8 is equal to 0. So this is the quadratic equation we are getting, and we need to calculate the roots of this. So when we simplify it further, the value of x, okay, so the factors will be minus 4 and minus 2. So x minus 4 will be one factor, x minus 2 will be the other factor, equal to 0. So we get x is equal to 4, okay, or x is equal to 2. Okay, so see, out of the given options, x is equal to 2. Option B will be the right answer. So simple, just we need to shift, make use of the definition and write sine inverse pi by 6 in form of sine pi by 6. Substitute sine pi by 6 and simplify it. So when we simplify, we get the value of x as x is equal to 4 and x is equal to 2. Okay. Next question we will be discussing, and see the similar questions which will repeat. You will try to do it for homework. Such questions I will be giving it for homework. Okay. And if there is doubt in any of this question now what we are discussing, you all just put it in the chat box. Okay. Just you can type it in the chat box. Don't unmute. Don't mute. Okay. Don't unmute yourself. Keep yourself mute. At the end of the class, Chaitanya, mute yourself. Okay. So see, next question. Okay. So in this particular question, it's given that see cos inverse of 1 by 2 x square plus x root of 1 minus x square into root of 1 minus x square by 4 is equal to cos inverse x by 2 minus cos inverse x. Okay. So this condition is given. Okay. And what must be the uh, x values? Okay. So what are the x values so that they will satisfy this equation? Okay. So see, on the LHS we have cos inverse, on the RHS also we have cos inverse. Okay. So here first what we will be doing is cos inverse. See, we are using okay, the range of cos inverse. We know the range of cos inverse is from 0 to pi. Okay, the range of cos inverse is from what? 0 to okay pi. Okay, so here what we are doing is first we are considering it in between 0 to pi. So here we can consider. So just see, we will be going through the solution of this question. So here we are considering the LHS. See, cos inverse is greater than equal to 0 and less than equal to what? Pi. Because cos inverse lies in 0 to pi by 2 when x is positive. Okay. See, the range of cos inverse function, the range of cos inverse function is 0 to pi. Okay, it is 0 to pi, and we know okay from 0 to pi. So see, when it is in the range of 0 to pi by 2, it varies from 1 to 0 and it is positive. Okay. So here what we are doing is in place of the LHS we are substituting the RHS. So the RHS part is cos inverse x by 2 minus cos inverse x greater than equal to 0, or on simplifying we get cos inverse x by 2 greater than equal to cos inverse x, or on further simplifying, see here just we are taking the coefficients. X by 2 will be less than equal to x. Okay. Or x by 2 is greater than equal to 0. It implies x is also greater than equal to 0. So a mod of x by 2 is less than equal to 1, or x is less than equal to 1, which implies x is less than equal to 1. So mod x is less than equal to 1. Okay, so we know modulus value is always greater than 0, and here we are getting the interval as less than equal to 1. So when we simplify, we get it in the form of x greater than equal to 0 and less than equal to 1. Okay, so the interval 0 to 1, okay, closed interval 0 to 1 will be the right answer. Next question. Okay, so here again the similar question is given where you need to determine the interval of x, and these you all do it for homework. 23rd question. Next we will be discussing the 24th question. See, in 24th question it's given if sine inverse x square minus 7x plus 12 is equal to n pi, for all n belongs to I, then x is equal to. Okay, So I think the question number 22, what we discussed was similar to this. Okay, just to shift. Students, mute yourself. Next, we will be discussing. So here the answer is 4 or 3. Same way you all do it. Okay. Next, solution set of the equation tan inverse x minus cot inverse x is equal to cos inverse 2 minus x is. Okay. So we need to calculate the solution set of cos inverse tan inverse x minus cot inverse x is equal to cos inverse 2 minus x. Okay, cos inverse 2 minus x. So here what we need to do is pay attention. So in question number 25, so we are considering the RHS part first. So the RHS, we can see cos inverse is existing. Okay, this RHS will exist. The RHS part will exist in what interval? So see cos inverse, again we need to consider the domain of cos inverse. Okay, the domain of cos inverse x is minus 1 to 1. Okay, the domain of cos inverse x is minus 1 to 1. Okay, so see the domain of cos inverse x. Okay, cos inverse x is what? Minus 1 to 1. Okay, so when we simplify this, we can consider 2 minus x. So this 2 minus x is greater than equal to minus 1 and less than equal to plus 1. It is less than equal to plus 1. So on simplifying it further, okay, so when we simplify it further, we get it in the form of, okay, so see when we simplify it further in terms of what? Sine inverse x, we will get it in the form of, so see 2 we are shifting it to the LHS. Okay, so this will be minus 1 minus 2. Okay, and then we are shifting. Okay, so see pay attention on simplifying this further, we get it in the form of, okay, we get it in the form of, see minus 3 less than equal to minus x less than equal to minus 1. Change the sign and make x positive, so it will be 1 less than equal to 3. So x, it will lie to the interval what? 1 comma 3. Okay, so x will lie to the interval 1 comma 3. So the option C will be the right answer, because tan inverse x is equal to what is given? Cot inverse x. Okay, so we are considering the domain of cos inverse x, simplifying it and finding the value of x. Okay, so x is belonging to the interval 1 comma 3. Okay, 1 comma 3. Yes. Okay, so along with me, you can start solving if you are able to do the solutions well and good. If you don't know, you can go through the solution. Okay, so try to take a pen and pencil in hand and try to solve it along with me. Okay, next, tan inverse of cot theta is equal to 2 theta, then theta is equal to, okay, so we need to calculate the value of theta when tan inverse of cot theta is equal to 2 theta. Okay, so here what we can do is just shift tan inverse to the LHS. So see we can write it in the form of, see cot theta is equal to tan 2 theta. Next, by making use of trigonometry, we can write this as cot of pi by 2 minus 2 theta is equal to what? Cot theta, or theta will be equal to pi by 2 minus 2 theta, or 3 theta will be equal to pi by 2, okay, or theta will be equal to what? Pi by 6. So the value of theta is equal to pi by 6. That is the option C will be the right answer. Here we are making use of the formula tan of pi by 2 minus theta is equal to what? Cot theta, and reverse of this is what? Cot of pi by 2 minus theta is equal to what? Tan theta. Okay, so we are trying to get the similar ratio on both sides, equating the terms, okay, and getting the value of theta. So theta is equal to pi by 6. Okay, simple question. Okay, next. So see, the question over here is the range of sine inverse x plus cos inverse x plus tan inverse x. Okay, so in the beginning of the class, I told you the domain and range. The domain and range of inverse trigonometric function is very important, playing a very important role in solving the question. So here they are asking the range of sine inverse, cos inverse, and tan inverse. Okay, so first what we will be doing is we will be uh, writing down their domains, so we will get the x values. And since the plus sign is occurring here in the equation, the sine inverse x plus cos inverse x plus tan inverse x, the plus sign, it indicates we need to take the intersection of their respective domains. Okay, and once we get the domain, we can easily find out the range of this given function. Okay, so here first step what we are doing is first we are trying to combine the range of these the domains of these functions. Okay, the domains of this function. So here first what we are doing is say sine inverse x plus cos inverse x plus tan inverse x. Okay, so for this first we are simplifying and writing down the range of this, the domain of this. So see the function for the given function. Okay, see the domain. Okay, for this given function, the domain of this, the domain, okay, of f is equal to, see the sine inverse x domain is minus 1 to 1, cos inverse x domain is also minus 1 to 1, and tan inverse x, the domain is R. So when we take the intersection, see minus 1 and 1 intersection, minus 1 and 1, it will be minus 1 and 1, the same interval. And when we take the intersection of minus 1 and 1 with real number, the smaller set is minus 1 to 1. So minus 1 to 1 will be the domain of this function. Okay, will be the domain of this function. So once we obtain the domain, next what we are doing is we are trying to simplify and obtain the range. Okay, so to obtain the range, see 1 minute, pay attention. This function, in this function, say sine inverse x plus cos inverse x plus what? Tan inverse x. Okay, so this function, see for what value this tan function is. See the tan function, okay, at minus 4 it will be minus pi by 4, and okay, and at plus 1 the value of this will be pi by 4. Okay, but we want this particular function. So see minus pi by 4 I'll keep as it is. Tan inverse already we have taken, and we know the value of sine inverse x plus cos inverse x is pi by 2. So pi by 2 plus tan inverse x will be less than equal to pi by 4. Okay, and when we simplify this, when we try to simplify this and obtain the value, we get it in the form of, okay, so see here what we need to do is we need to add pi by 2 to the LHS also. We need to add pi by 2 to the RHS. So when we simplify, we get it in the form of, okay, we get it in the form of, so see pi by 2 minus pi by 4, it will be plus pi by 4 less than equal to pi by 2 tan inverse x less than equal to, see pi by 4 plus pi by 2, it will be equal to 3 pi by 4. Okay, so you can see the given function f of x it is lying between pi by 4 and then 3 pi by 4, when x is lying between what, minus 1 to 1. Okay, so out of the given option, okay, option B will give us the right option, that is pi by 4 and 3 pi by 4. Okay, so in this question, first what we have done is we have calculated the domain, and then using the domain we are calculating the range of this given function. Okay, a range of this given function. So just most of you have marked A as the option. Okay, it's not A. And just check it once again. Go through the solution. Okay. Okay, next question. Tan of pi by 4 plus, okay, tan of pi by 4 plus 1 by 2 cos inverse x, and tan of pi by 4 minus 1 by 2 cos inverse x is equal to. Okay, so this question we are making use of substitution method and simplifying it. Okay, we are making use of substitution method and simplifying it. Okay, so see, pay attention here. So here what we will be doing is we will be substituting a 1 by 2 cos inverse x as theta. So when we substitute 1 by 2 cos inverse x as theta, what do we get? See, okay, so here what we are doing is we are making use of substitution. 1 by 2 cos inverse x is equal to theta. Okay, or see, what do we get? Cos inverse x is equal to 2 theta, or x is equal to cos 2 theta. So see, the above equation will be now in the form of tan of pi by 4. Okay, pi by 4 plus 2 theta. Okay, plus see, cos 2 theta. So see, we have considered this as theta. So it will be pi by 4 plus theta. Okay, pi by 4 plus theta plus tan of pi by 4 minus theta. Okay, so on simplifying, see, tan of pi by 4 plus theta, it will be of the form, when you make use of the formula tan of a plus tan of x plus y, we get tan pi by 4 as 1, and then tan y it is equal to theta divided by 1 minus tan theta. Similarly, for pi by 4 minus theta, we get it in the form of 1 minus tan theta upon 1 plus tan theta. Okay, so when we simplify it, we get it in the form of 2 plus 1 plus tan square theta divided by 1 minus tan square theta, which on simplifying we get it in the form of, so see, 1 plus tan square theta upon 1 minus tan square theta is nothing but cos 2 theta. Okay, see, cos 2 theta from trigonometry, the formula of cos 2 theta is 1 minus tan square theta divided by 1 plus tan square theta. So we are simplifying it. We are getting it in the form of 2 upon cos 2 theta. Or on further simplifying it, we get it in the form of cos 2 theta. We have considered it as x. So it will be equal to 2 divided by x. Okay. So the option D will be the right answer. Option D will give us the right answer. Okay. Option D will give us the right answer. Next question, very important question. Most of the times this question has been asked in the competitive exams, and this has been occurred in JEE example, as a JEE example also. Okay, in JEE exams as well as in most of the CETs. This question is asked state CETs. So see, pay attention here. The numbers, the number of triplets x, y, z. Okay, the number of triplets x, y, z satisfying the equation. Okay, the satisfying the equation sine inverse x plus sine inverse y plus sine inverse z is equal to 3 pi by 2 is. Okay, so see, Here, when the sum of sine inverse x plus sine inverse y and sine inverse z is equal to 3 pi by 2, we can see that x, y, and z. Okay, if we consider sine inverse x as pi by 2, see sine inverse x as pi by 2. Okay, so when I consider sine inverse x as pi by 2, so if I consider see it in the form of, suppose the first value is pi by 2, the second value is also pi by 2, and the third value is pi by 2. So when we add pi by 2 three times, we get 3 pi by 2. Okay, so here what we can do is we can consider a sine inverse x is equal to what? Sine inverse y is equal to sine inverse z is equal to pi by 2. Okay, and when sine inverse x is equal to pi by 2, we will get the relation x is equal to y is equal to z is equal to 1. Okay, so when we substitute here x is equal to y is equal to 1, so here the satisfies the equation. So one solution will satisfy, and that is option A will be the right answer. Okay, so we get option A as the right answer when we substitute x as pi by 2, y as pi by 2, and z as pi by 2. Okay, hope you are understanding it. So again, there is a same type question, and I think in 34 or 35, the same type question is asked in terms of cos inverse, and there to be and need to make use of the same result, but there the question is in the form of cos inverse x plus what? Cos inverse y plus cos inverse z is equal to 3 pi. Okay, is equal to 3 pi. Okay, so here instead of 3 pi by 2, 3 pi is given. Okay, so we can consider this as pi, pi, and pi. So here instead of getting 1, we will be getting minus 1 as the answer. Okay, next we will be discussing question number 30. Pay attention. Okay, so the question number 30. Here, just I will be giving you the hint. You all do it for homework because it's little bit lengthy. The calculation is lengthy, but example is easy. And I think while preparing for board exams, you might have come across this question. So here, see, three functions have been given in terms of tan. Uh, so tan inverse x minus 1, tan inverse x plus tan inverse x plus 1 is equal to tan inverse 3x. Okay, so here what we need to do is apply the formula of tan inverse x plus tan inverse y. So first apply tan inverse x plus tan inverse y for x minus 1 and tan inverse x plus 1. So whatever the result answer you get, you again apply the formula with respect to tan inverse x. So you will get LHS is equal to RHS. Equate the coefficients, you will get a quadratic equation. Simplify it, you will get the value for what? X. Okay, so here just some steps I will be explaining you, some steps. Okay, so you can make use of the result. Okay, so see here what we can do is first two steps I will be explaining it, and then the rest part you can simplify. Okay, okay, so see, pay attention here. So tan inverse x minus y plus tan inverse x plus 1, you can keep it as it is on the LHS, and then we can consider this as tan inverse 3x minus tan inverse x. Okay, so apply tan inverse x plus tan inverse y on the LHS, and apply tan inverse x minus tan inverse 3x, same formula on the RHS. Okay, so when we simplify this, okay, when you simplify this, we will be getting it in the form of, okay, we will be getting it in the form of, so see there. See there, first step, after doing the first step, you can see here. So tan inverse x minus 1 plus tan inverse x plus 1, on simplifying you are getting 2x upon 2 minus x square, which is equal to, on the RHS you are getting 2x upon 1 plus x square. So when we simplify, when we cross multiply, we get it in the form of 2x into 1 plus 3x square, 2x into 1 plus 3x square, which is equal to 2x into 1 minus x square. Okay, 2x into 1 minus x square. Say 2x into 2 minus x square. So when we simplify this here, we are getting a quadratic equation. So when we simplify this quadratic equation, we get 4x square minus 1. So 2x is equal to 0, x will be equal to 0. And 4x minus 1 is equal to 0, we get x is equal to plus or minus 1 by 2. Okay, so here we are getting two values, that is 0 and plus or minus 1 by 2. So the option D will be the right option. Okay, so once again you all try to solve it later. Next, question number 31. So if tan inverse 1 minus x upon 1 plus x is equal to 1 by 2 tan inverse x, x is greater than 0 less than 1, then x is equal to, okay, then x is equal to. So see, this is again a similar question. We need to simplify. Pay attention here. So in the question number 31, see, we are shifting the two, and we are getting it in the form of tan inverse x is equal to 2 tan inverse 1 minus x upon 1 plus x. Okay, so here we are making use of the formula 2 tan inverse x is equal to 2 tan inverse x. Formula is 2x upon what? 2x upon 1 minus x square. So this is the result. So in place of x, here we have 1 minus x and 1 plus x. So this will be in the form of 2 into 1 minus x upon 1 plus x divided by 1 minus x upon 1 plus x whole square. So on simplifying further, what do we get? See, in the denominator we take the LCM. The LCM will be 1 plus x square. So 1 plus x square minus 1 minus x square. Okay, and in the numerator we already have 1 plus x. So 1 plus x and 1 plus the LCM will cancel off. Okay, and on simplifying we get 2 into 1 minus x square upon 4x. Okay, so now further on simplifying, see, x will be equal to, this x will be equal to 1 minus x square upon 2x. So we are getting again a quadratic equation. So we get 3x square is equal to 1, or x square is equal to what? 1 by 3, or x will be equal to plus or minus 1 by root 3. Okay, so question number 30 as well as what 31, both are similar. So just we had discussed the result on tan inverse x plus tan inverse y. So this result is important, and then the formula for 2 tan inverse x. Okay, so both the results have been used in the formula example number 30 and 31. Okay, so be perfect with these two formulas. These are very important. Okay, next question. Okay, so question number 32. Okay, so 4 tan inverse 1 by 5 minus tan inverse 1 by 70 plus tan inverse 1 by 99 is equal to. Okay, so here just the first step we will be discussing, and it's same like 30th example what we have done. Okay, the same steps we need to repeat here. See, pay attention here. See, the first step what we can do is 4 tan inverse x, it can be written as 2 into 2 tan inverse 1 by 5, and then we can write it as C minus 1 by 70 plus what? Tan inverse 1 by 99. Okay, so here for these two terms you can apply tan inverse x minus tan inverse y formula, and here we can make use of 2 tan inverse x formula. Okay, so if you make use of the result for 2 tan inverse x and tan inverse of x minus tan inverse of y, now you will get the value of x. So simplify it. Okay, okay, on simplifying, the answer will be equal to pi by 4. Okay, so do it for homework, this question. Okay, so the answer is pi by 4. Next, a very direct question here. So this is based on the formula. So here what we need to do, see 3 tan inverse A is equal to, okay, 3 tan inverse A is equal to, okay, so here we know the formula for tan 3 theta. Yes, we already know the formula for what? Tan 3 theta. So using that, we can write the result for 3 tan inverse A. Okay, 3 tan inverse A. Just see 1 minute. The formula for uh, tan 3 theta is equal to what? 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Okay, so this is the formula. So here what we need to do is just we need to shift this tan on. So replace, consider tan theta as x, and if you simplify, you will get the result for what? 3 tan inverse A is equal to, see 3 tan inverse A is equal to, where there is tan theta, replace it by a, so it will be equal to 3a minus a cube divided by 1 minus 3a square. Okay, so 3a minus a cube divided by 1 minus 3a square, and that is the option D. Okay, so the option D will be the right answer. So this is a direct formula. You need to know the formulas. So if you know the formulas, you will find the examples interesting. Okay, so you need to come prepared with the formulas. So already the schedule is given to you. Okay, so whichever the next chapter is there, try to come perfect with the formulas and the related theory, so you will understand maximum questions. Okay, next. Very so this question has been picked up from your NCERT. Okay, so sine inverse 1 by 5 plus cos inverse x is equal to 1, then x is equal to, okay, then x is equal to. So here what we can do is, see, just we are shifting. See, sine inverse 1 by 5, we are keeping it as it is, cos inverse x as it is. Now shift sine to the LHS, so it will be sine inverse 1. Okay, so what we are doing is, by making use of the definition, we are getting it in the form of sine inverse 1. And we know sine inverse 1 value is pi by 2. So see, sine inverse 1 by 5, a cos inverse x is equal to pi by 2. Okay, or we know when the value is equal to pi by 2, when sum of, see, using this formula, sine inverse x plus cos inverse x, if it is equal to pi by 2, meaning is the coefficient of what? Sine and cos, that is the angle, whatever x value is there, that must be same. So here for sine theta, the x value is 1 by 5, so cos will also have the same value, that is x is equal to 1 by 5. So the option D will be the right option. Okay, so here we are making use of the result sine inverse x plus cos inverse x is equal to pi by 2. Okay, next. Okay, the equation 2 cos inverse x plus sine inverse x equal to 11 pi by 6 has. Okay, so they are asking whether the above equation has solution, no solution, only one solution, two solutions, or three solutions. Okay, so here we need to find out the value of x, and once we find out the value of x, we will get to know, okay, how many values of x are existing. So if one value is there, it will be one solution. If two values we are getting for x, then it will be two solutions, and so on. Okay, so say in this particular example, what we can do is, so just by making use of the formula, see what we can do. Two x, I can write it as cos inverse x plus cos inverse x. So this two, we are splitting it as cos inverse x plus cos inverse x plus sine inverse x is equal to 11 pi by 6. Okay, or say by making use of the result cos inverse x plus sine inverse x, it is equal to pi by 2. So plus pi by 2 is equal to, plus pi by 2 is equal to 11 pi by 6, or on simplifying we get 6 is equal pi by 6, 11 pi by 6 minus what? Pi by 2. Okay, so we know 11 into 30, it will be 330. Okay, minus 90. Okay, minus 90. So we will be getting it as 200 and what? 240. Okay, so 240. But say cos inverse x is equal to 240. This 240, that is 4 pi by 3. Okay, 3 pi by 4, 240. Okay, or 3 pi by 3. You can write it as okay, 240. That is 60 into 4. Okay, so 4 pi by 3. So this 4 pi by 3 or 240, it will not belong to the range of cos. See, the range of cos is 0 to pi, but when we see the solution here, it is 240. This 240 is not belonging to the range 0 to pi, so there will be no solutions for this equation. Okay, there will be no solution for the given set of equation. Okay. Next, cot inverse x plus sin inverse 1 by root 5 is equal to pi by 4, and then x is equal to. Okay. So here they have given the value in terms. See, we don't have any formula for cot inverse x plus sin inverse x. So here the first step what we can do is convert cot inverse x in terms of tan, and also convert sin inverse x in terms of tan, and then make use of the result tan inverse x plus tan inverse y. Okay, we can make use of the result tan inverse x plus tan inverse y. I will give you 1 minute. You all try it and try to tell me the value of x. Okay, be quick. Okay, so try to solve Jyoti, Kavya. Try to solve it. What will be the answer? First, convert cot inverse in terms of tan. You can make use of right angle triangle. Okay, so we know if we consider this as theta. Okay, so cot inverse x will be opposite upon adjacent upon base. So this will be x upon 1, or this will be root of what, 1 plus x square. So see, tan inverse will be equal to it will be equal to 1 divided by root of 1 plus x square. And when we simplify this, sine inverse. Okay, sine inverse. So see, pay attention. Opposite upon okay, hypotenuse. So root 5 square will be 5. So 5 minus 1, it will be 4, which is equal to 2. And then tan inverse 1 by 2. Okay, so this will be the value. So this will be tan inverse root of 1 plus x square, and the second term will be tan inverse 1 by 2. So by making use of the above result, what do we get? See, we'll check. Okay, so one of Jyot Kavya has answered it as a B. Okay, so we will check it. Okay, so say tan inverse 1 by x and then tan inverse 1 by 2, which is equal to what? Tan inverse 1. Okay, so on simplifying it, we get tan inverse 1 minus tan inverse 1 by 2, which is equal to 1 by 3, or x will be equal to 3. Option A will be the right answer. Next. Next question. So say cot of cos inverse x is equal to sec inverse sec of tan inverse a upon root b square minus a square. So again we have to make use of the same method. So see, we will simplify this. Say tan theta is given to us. So again make use of a right angle triangle. So if I consider this angle as theta, say tan inverse is opposite upon a upon what? Opposite upon the base, that is b square minus what? A square. So when we square it, we get the value as root and root will cancel. Okay, this value will be b. Okay, so this value will be b. So we can get sec inverse in the form of, see, outside sec is there. Okay, so we need to write this complete term in terms of sec inverse. So we can write it as sec of sec inverse. Okay, sec inverse, it is equal to, sec inverse is equal to base. Okay, x square minus what? A square divided by what? B. Okay, so this will be the value of what? Sec inverse. So sec inverse we will be getting, so this will be equal to root of b square minus a square upon what? B, which is equal to cot of cos inverse x. Okay, or see, we want x value, so cos inverse x will be equal to cot of root of b square minus a square upon what? B. So when we simplify here further, what do we get? When we simplify it further, what is the base? See, what is the base here? Opposite side will be b, adjacent side will be b square minus what? A square. And again when we simplify, here we get it as a. So if I try to write cos a, see from here, cos a will be equal to what? B upon a. Okay, so when we simplify, cos a will be equal to, see, 1 minute, when we square it and add it, it will be 2b square. Sorry, this will be 2b square, 2b square minus a square. Okay, so when we write the value of cos, we get it in the form of cos inverse is equal to. Okay, so the final step, we will be getting it in the form of, pay attention here. So the final step, we will be getting it as, see, we will be getting it as b upon root of 2b square minus a square. Okay, because the base is b. Okay, and the hypotenuse is root of 2b square minus a square. So option A will be the right option. Okay, next, and another two questions we will be discussing. So here you see, again it is given in the form of tan inverse tan x upon 4 plus tan inverse 3 sin 2x upon 5 plus 3 cos 2x. Okay, so here in this particular example, question number 38. So in this example, what we can see is, again the function is in the form of what? Tan. Okay, so we need to simplify it by making use of the formula tan inverse x plus tan inverse y. So apply that formula and simplify it. The answer will be equal to x. Okay, so it is similar question. Apply the formula. So see, for sin 2x, we need to substitute it in terms of tan. It will be 2 tan x upon 1 plus tan square. And cos 2x, trigonometric formula, it will be 1 minus tan square upon 1 plus tan square. So on substituting and simplifying, we get this. And on simplifying by making use of tan inverse x plus tan inverse y, we get the final answer in the form of x. Okay, this we have done it directly. Yes, we have 4 tan inverse, you need to write it as 2 into tan inverse x and simplify it. The answer will be equal to pi by 4. Okay, so now see this one, question number 41. Tan inverse 1 plus tan inverse 0, tan inverse 2 plus tan inverse 3. Okay, so this question, you can see it. How we can do is, okay, just what we need to do here is, see, pay attention there. Tan inverse 1 we know, tan inverse 1, what is the value we know already? It is pi by 4. Next, tan inverse 0 is 0. and then apply the formula tan inverse 2 plus 3 divided by 1 minus 1 minus 6. Okay, 1 minus 6. So we get it in the form of pi by 4 plus 0 plus tan inverse of minus 1. And tan inverse of minus 1 is what? Tan inverse of minus 1 is minus tan inverse. Okay, in which quadrant it is negative? Tan is negative in. Okay, so tan inverse of minus theta will be minus minus tan inverse 1, or this will be equal to pi by 4. Okay, pi by 4 minus pi by 4. So pi by 4 minus pi by 4, the value will be equal to what? 0. And out of the given option, okay, none of these, okay, none of these will be the right option. Okay, so none of these will be the right option. Okay, so we have discussed few questions on inverse trigonometry. Okay, and again some more questions are given in the PDF. You can go through those questions. So in the tomorrow session we will be discussing examples on matrices and determinants. Okay, so similar questions you all try to do it for homework. So we will meet tomorrow. Okay, take care, bye.